This session is being recorded. So yeah, so as we'll be writing code, feel free to unmute and jump into discussion, share your opinion, and who knows, there'll be a better way of doing the same thing, and we'll explore that. We'll discuss it. We'll reason it.
Sorry, I actually had one question from the quiz.
Okay, what was that?
It was the third to last question.
Third to last question. All right. Which is 1, 2, 3. Is this is public class test 2, right? What is the output of following code? It's integer with so many things. Amount is 2. All right. So, what is your question?
So when I was going through it in my head with the numbers,
Mm-hmm.
I got the first value to be 12.
First
Like it
value
should have
to be
started
12.
with 12 for me. It should have been like 12, 14, 24, and 10. I don't know how there was 2, 2, 4, and 2.
So that's very interesting. Now, if you look at the for loop, the first for loop, int I starts with 1. So in the values array, index 0 is 2. So we are not changing anything at index 0 at all. We are starting to change everything from index 1 onwards. So 2 is going to be as is, it won't get affected. But the next to that is at index 1 is 6.
Oh, so it still print 2. Okay, I didn't think it would print 2 because I didn't pay attention to the second for loop.
Yeah. So in the first for loop, we just start from 1. So we don't touch the 0th element.
Okay.
So
Yeah,
it will
that
just
makes
get
sense.
printed as is. And then everything else gets multiplied by 2, I guess.
Yeah, okay.
So yeah,
Yeah, okay.
C will be the answer. Any other question? Anyone else? All right, I'm sharing my screen, and if all right, so as there are no more questions, we'll move on. So in the last session, we looked at. Well, I didn't erase my whiteboard. I hope you all can see it. What we did was we had an array of integers, and the task was to write a code to find a maximum. To find the minimum value among all the elements here. And what we did was very intuitively simple. We kind of used the fact that integers in Java cannot exceed beyond the max value, integer dot max value. So if we need to find the lowest integer in the array, it must be below that. So that's how we start, and we start comparing each element. And every time we find a smaller value than the max value, we update the last found smaller value. So let's say if the max value is integer max value is, let's say, some 1000, just arbitrarily, it's a big number, just for the sake of simplicity. Let's say max value is 1000. We compare the first element and say, oh, 5 is smaller than 1000. So my new smaller element in this array is 5 so far. Go to the next one. Is 1 smaller than 5? Yes, 1 is smaller. So, okay, now I found a new smallest element. So I'll update my int s to 1, saying this is my smallest element so far I have seen in the array. We move to the third element. We see 30. Is 30 less than s? No, s is 1. So far, our smallest element is still 1. And we keep doing it. In the next, we come across 0, and we see, is 0 less than small, which is 1? Yes, 0 is less. So we found another low element. And we update s to 0 now. So this is the smallest element so far. Next 15, that's not smaller than 0. Next is 2, that's greater than 0, 2. We move on to the next one, is negative 10. Is that less than 0? Yes. So we update our smallest value found so far to minus 10. And that's the smallest element we have found so far. And then finally, we reach to 20, which eventually becomes the smallest element in this case. So we wrote this simple code which says if the we loop through the in the array by index, which is look at every element, and we say, is that element less than the smallest value we have seen? if it is, then update the smallest value and say, hey, this my new smallest value is whatever is that at whatever is that at that index. And at the end, we return whatever the smallest number is, right? So this trick we used to find the smallest. Now we're going to build upon this, and we are going to find the largest element from the array. So through visual inspection, we see 30 is the largest element in this array. But the question is, how will we write a program to do that? Now, visually, when we look at certain things in this array as an example, how do we know 30 is the smallest element? We know that only when we have seen everything, right? So the fact here is to find out if whatever element we are proposing to be the largest or the smallest, we know that only when we have seen every element of the array. And if this was hidden from you, and there could be any number in that hidden area, and there was no way to find out if 30 is the largest or not. So we can't break the loop unless we have seen everything in the array. You all agree with me, and are we all on the same page? Any questions so far? All right, no questions. So the ask is to write a program given an integer array. It should return the highest value among all the elements of the array. In this example here, 30 will be that. Now, how will we get the intuition of writing this code? Well, we can kind of borrow the same intuition we had last time about getting the lowest. Is the lowest number in this array will always be lower than the max value of integer allowed. You can't go beyond it, so everything is going to be less than that. Now, we need to find the maximum value, so you can't go below min value, right? So we'll start with our comparison. So we'll say, so far, when I have not seen any element in the array, so far the lowest or small, well, so far the largest element we know of is the lowest integer value. And then we'll compare each element and say, is this bigger than what I've seen so far? Yes, 5 is bigger, so 5 becomes our next biggest element. Now we move on to the next one. So far we have seen the array till index 2 which at index 2 is 1 bigger than 5? 1 is not bigger than 5. So far 5 is the biggest element. We move on, we come to 30. We say, okay, 30 is bigger than 5. We update. So far the biggest element we have seen is 30. We continue doing that throughout the array, and then at the end, whatever element the biggest we have seen will be returned. So if quickly let's switch to our code and start writing it. You all can see my computer here, right? The IntelliJ. So let's write the program. We'll create a static function. We don't want to create an object for this, so we'll just create a static method. We'll say it's public, so we can call it static integer find maximum. We need to find the maximum from an integer array. Let's call it ARR, right? Given an array, we need to find the maximum. So what we do is we say int max. So far we have seen is we know that nothing can go lower than min value. So at the worst case, all elements of array will be min value, and that would be the max in the whole array because they all match min value. Now we'll go through the array starting at index 0 and all the way to the length of array. So we'll visit each element. And how do we travel through the array? One at a time, one element at a time. So we increment I by 1, and we check if the current element that we're looking at in the array, ARR at index I, is that greater than my max so far. If if it is greater than the max I've seen so far, then update my max. This is my new max. What is the new max? It's ARR, whatever value exists at index I. So once we have gone through the array, at the end, what we're left with is the maximum from the array, right? Now, let's quickly run this. Now, last time we kind of we had created an array with.
Could you go back? I didn't really finish.
Okay, my bad. Let me go back. Okay.
Okay, thanks.
Did you finish writing it?
Yeah, I did.
Okay. So let's go to the main of our program, and then we'll reuse the array that we had previously created. These are just random numbers from it, but this time we want to find the maximum value. So we'll say system.out.println max value is, and then we'll say find elements dot max from all the numbers that we have. Okay. So let's run this program and see if we get the right result. So we do get the right result. 30 is indeed the highest element in this given array. So this technique works, right? So it is as simple as that to find the lowest and the largest, highest numbers of a given array. Any questions or confusion so far? Now, if no questions, then I have a question for all of you. So feel free to unmute and jump in. The techniques that we saw, they work only in few conditions or cases. First of all, it is based on the idea that the integer max and min values are kind of an upper bounds or the lower bounds of our search. So no number can go beyond max and min. So that's the whole solution is based on this idea, and which makes it very limiting. So we can use this only to find max and min of an integer array or a double array because they support max value and min value. How about if we need to, if this was an object of people, there were 10 people in the line and you wanted to find who's the youngest and who's the eldest of all, this technique would not work. Well, it would work, but the point here is it's not very scalable. It won't work in all conditions. It will work for few data types just fine. Second problem with this approach is now when we found the min value, we went through the entire array once, right? When we found the max value, we went through the same array again twice. So every time we try to find something in the array, we end up going through the entire array, right? So this is just a it's an 8-element array. But if this array was like 100,000 elements, then the programs become very slow, right? So so this is not a very efficient technique of doing things. And finally, with this technique, we can find only max and min elements of the array. How about if we need to find, give me the fourth largest element, or second lowest element, or something of those kinds. How about we need to find, run these queries multiple times on the same data set? Then this is not going to work. So how like unmute your mics and let's talk about how would we solve the problem of if the question is to find, give me the fourth largest element from this array. How would we do that? How will we build the intuition of doing it? Guys, I need everyone's input on this. I can give the solution, but that's not the point here, right? We are not here to practice how to type using a keyboard and in IntelliJ, right? We are here to practice how to build intuition to write good programs. So I'll just randomly pick a few names, and if no one is volunteering, yes, do you want to talk about building the intuition of how would you solve a problem wherein given an integer array, find the fourth biggest element? How would you do that?
I make like a variable that holds your. Man, I don't really know how to.
Let me white clean this so that it doesn't distract you. So the ask is given an array of integers, it could be 1 million of them, and we need to find the fourth biggest element on it. And Yash, you're not coming up with ideas. Let's see if anyone else. Grace, can you think of a way to do that? No one? No. How about Parashar?
This is kind of weird. I don't know how it would work, but one way that I was thinking of it was, so when you, for example, if we're trying to find if we're trying to find the fourth lowest one, like in our first function, we see in minimum is equal to integer that max value. So maybe instead of that, we could have, I don't know, int a minimum is equal to integer dot max value minus 4, or something like that. I don't really know.
No, that may quite not work. Like even in this example, let's say if we do max minus 4, then still we'll end up finding minus 20 as the lowest. We'll not be able to say that the fourth lowest element will be minus 20, 10, 2. So 2 should have been the right answer, but we would not have found that using that solution.
Yeah, I don't really know. That's just something that I thought might work.
Okay, it's a good try. It's a very logical try. It's an extension of what we did. How about Gavin, Ali, and Zain? You guys have any inputs, any ideas on how to do that? Now let's connect this with a real life problem, right? So let's say there is a line of people, and then we need to find out who's the second eldest in the whole line. How would we do that? No, we can't go and ask age to everyone first, saying, okay, let's
Actually,
find who's
I have
who's it.
an idea now.
Okay.
Well, I think what you could do is we already know how to check the max one, right? So we could first we check the max one. Then after we check that one, we remove it and we add one to some sort of counter. And then we keep doing that until the counter reaches 4. And then that's when we know it's the fourth.
That's actually a really good solution. That's really nice. Okay. So what the idea here is to go through the array one time and find the lowest element and remove that from the array. Now, whatever is left in the array, we go through that array again and find the lowest. Now, whatever we find, we remove that again, and we keep doing it 4 times. So in the 4th iteration, the element that is lowest in the array is the 4th lowest, right? It makes sense. It's kind of intuitive, but there's a catch to the problem. Catch to the solution. The problem with that solution is, first of all, we'll have to somewhere store those removed elements. Right? So, well, we really don't want to store it, but essentially what is happening here is when we delete an element from the array, we have to move the remaining elements one step right or left, correct? So let's say if we remove one, then we need to move everything following it one step to the right, or to the left in this case. So if your array is too big, then that operation is going to be lengthier. Now, the second problem is, if we say, let's say, find the sixth smallest element, then we repeat this 6 times. If we say 100th smallest element, we repeat the same process 100 times. So we're going through the array so many times again and again and again and again. So that's such a waste of computing power, right? Is there a better optimal solution to this problem? Now, just imagine a case wherein uh, people stand in a line of different heights, and we need to find who's the who's the second taller person in the line, or maybe let's say third taller person in the line. So how would we do that? Now, won't it be easier if we can rearrange everyone to stand in their ascending order of height? So if someone says, "Give me the third tallest person," then we just pick the person from who's third in the line, right? If someone says, "Give me the fifth smallest, tallest person now," so we just go and pick the person who is fifth in the line because we have arranged them in an ascending order by their
I have a
heights.
question.
Yes.
I don't know if this is what you were just talking about, but is there any way for us to put the values in an array, like in a specific order, like from lowest to highest? Is that what you were trying to say?
Yeah.
Okay.
Yeah. I'm trying to get to is, if we can sort this array, then we can find anything like, fourth smallest or
Yeah.
fifth smallest element, or could be anything, give me the largest element. We know largest element is always going to be at the end. So we just do array and then
Yeah.
the length, and it gives us the result.
Hmm.
So right, so we are all on the same page. So once we sort this, let's say we sort it in the ascending order. So smallest comes first, and the largest element goes last. So after the sorting, what we be left with is um, so minus 20 is the smallest. So we have minus 20 there, followed by a minus 10, followed by 0, 1, 2, 5, 15, and then finally 30, right? So we have arranged all elements in a certain order, which is ascending order in this case. Now the question is, give me the lowest element. Lowest element is always going to be at index 0, no matter what, because it's a sorted element, sorted array. So we quickly say, okay, minus 20. How about the biggest element? It is always going to be at the end. So we say, okay, whatever the length of array is, minus 1, go to that index and get the result. We say, okay, give me the second largest element. Length of array minus 2. That index is 15. That's the second largest element. So it makes things so easy when it comes to querying the array based on, run these queries. So essentially, we have optimized our solution. So we are not going again and again through the array every time to answer these questions. We go only one time, which is the work we do is upfront, which is we get an array, we sort it, and then now we can run all these queries so easily, right? So we all on the same page about sorting. All right. So when sorting looks like a good solution in this case, let's try to write a program which can sort an integer array. Now, there are a lot of ways to sort integer array, or in fact, there are a lot of ways to sort, but the one that we are going to implement is the most primitive one. It's the most intuitive way of sorting. It's called the bubble sort. I don't know if you all have heard this or not before, so I quickly go over it. So what bubble sort is, like how in a container of water, a bubble rises up slowly, going through the column of water. Similarly, the the idea here is, given an array, the smallest element will bubble all the way to the top. Right? So in this case, 20 will bubble all the way to the zeroth element, and as it passes through the array, everything else goes one step back so that it can create a space for the smallest element to come fit in. So, so we'll try to quickly build the intuition of how to bubble sort and form an array. Okay? Um, so what we so to do that, okay, we quickly okay. So now, so the way we'll write the bubble sort is as we said in bubble sort, the smallest value will bubble all the way to the top. In this case, from the last index to the first index. And how many times do we? So the idea here is now let's start from the end of the array. Let's compare -20 and -10. So we're going to arrange everything in an ascending order, which means smallest element comes to the first and then the largest goes out of the back. So let's start from the end of the array. Let's compare these two elements. It is -10 and -20. Is -20 smaller than 10? -10? Yes, it is smaller. So we need to swap these two together. So our array will become so if the right hand is smaller than the left hand, then we switch them. That becomes -20, -10. Everything else remains the same. Right? Now we compare these two. Is -20 less than 2? Yes, it is less than 2. So we swap them. So this remains as is. As -20 is less than 2, we swap. This becomes -20. This becomes 2, 15, 0, 30, 1, 5. So we see that our -20 is slowly going up the array. So what happens next? We compare. We compare -20 with 15. Is -20 smaller than 15? Yes. So we do a swap again. That is, we swap them. Remaining everything else is as is. 31, 5. Repeating the same process. Is -20 smaller than 0? Yes, it is. So this gets swapped. Everything else remains as is. How about 30 and -20? -20 is smaller, so that gets swapped. 30, 0, everything else remains as is. So in every try, when moving one element to the left. How about in the next iteration? Is -20 less than 1? It is. So this gets swapped again. This is 1. Everything else remains as is. 10, 5, and finally, in this equation, we do Is minus 20 less than 5? It is. So this gets swapped. 5, 1, 30, 0, 15, 2, minus 10. So now what we have observed is after going one time through every element of the array, so let's say how many elements do we have? 1, 2, 3, 4, 5, 6, 7, 8. How many times do we loop? 1, 2, 3, 4, 5, 6, 7. Okay? So 0 is that, and then 7 times we have loop, so that makes it 8. So in one time that we have gone through the array, we have the smallest element appear at the 0th index, right? So now, how many more elements are left to sort? The only elements left to sort are from 5 to minus 10, right? Because we know that the 0th element is already at its right place. So there's no need for comparing again. Right? You know, if we compare any element to minus 20, we are not going to do a sort because minus 20 is the smallest. So every time we reach the end, we have one element at the right place. So when that element is at the right place, we don't have to compare anything with it going forward. So next time, which is next set of iterations, what we'll do is we'll compare only between, so this is only between index 1, which is 5, through index 7, which is minus 10. We need to compare only those. So we need to go through the array only 6 more times to have the second lowest element over here, and then we kind of switch switch our so essentially when we do that, we'll end up after 6 iterations. What we'll end up seeing is we'll have this as minus 20 because this doesn't move. The next set of iterations, this becomes minus 10, and everything else moves one by to the right by 1. So 5, 1, 30, 0, 15, and 2. So we get this as a result, which means the two elements.
I have a question.
Yes.
I don't know if you were in the middle of explaining, but if you keep going, like, wouldn't you move into the path that, like, for the 2, like, the 0 is in front of the 2, so then the 2 would only move forward 1, and the 0 would still be there. Like, would you kind of run into an issue? Like, would you have to, like, wait, move the 0, and then again go back to the 2 and move it? Like, I don't know how to explain this. I just kind of kept doing it, and then I kind of ran into that issue. Like, I don't know how you would solve that.
You're right. Okay, let's get to it. We'll run that one case, right? We'll run it together, right? We can get it. But before we do that, let's convince ourselves that when we iterate between these the remaining elements after finding minus 20 as the lowest, we'll see that negative 10 is the second lowest and it occupies the index 1 in the array. So what we are then left with is to compare from index 1, which is 5, to index 7, which is 2 now. In this case, visual inspection says 0 is the next lowest, right? So after this iteration, where 5 is, there should be a 0. So let's run it through our mind. And so I'm going to erase everything, and I'm going to rewrite this last array just as a reference, so we know where we are going with. But any other question so far on how we are bubbling through the array? I'll use a darker pen so that it's more visible. I'm going to rewrite this before I erase it so that that becomes a good starting point for us. So now, after 2 iterations, what we have is we have minus 20 is in the first iteration we found. The second iteration we found minus 10 being the smallest, and the remaining elements are 5, 1, 30, 0, 5, and 2, right? I think this is going to answer the question. I'm going to erase that, and now we have done that. We have done that. Now we start from index 2, which is 5. So in the next iteration, what we have is Minus 20 remains as is because we are not comparing it with anyone. Minus 10 remains as is. And the question of remaining elements, we start from the end. Is 2 smaller than 5? Yes, 2 is smaller than 5. So this is going to switch. This becomes 5, this becomes 2, 0, 30, 1, 5. Right? So how about the next iteration? The next iteration is 2 smaller than 0? No, 2 is not smaller than 0, so we are not going to swap them. So what we end up is, nothing gets swapped, everything is as is. Right? But are we done with the iteration? We are not done with the iteration yet because we need to come all the way till 5. So we saw that in comparing 0 and 2, 0 is smaller, so we don't swap, we leave it as is. In the next iteration, we'll compare 0 and 30. So these two remain unchanged because there's no need to compare it. Now we compare these two. Is 0 smaller than 30? Yes, 0 is smaller than 30, so swap them. And everything else remains as is. Right? Now let's run the next loop. This remains as is, this remains as is. 5. Now, is 0 smaller than 1? Yes, 0 is smaller, so that's going to swap. And then everything remains 32 and 5. Right? Now, in the next iteration, minus 20, minus 10. Is 0 smaller than 5? Yes, 0 is smaller than 5. 0 and 5 swap. 1, 30, 2, 5. Right? Do we need a next iteration? We don't need a next iteration is because this was our starting point. And now, after comparing, so we started from here. We started from there, and this is our end point, and our start index is equal to the end index now. So that's why we stop. Right? So in the third iteration, we have 3 elements at the right place. So these are the top 3 or the 3 elements arranged in the ascending order. Now what we need to do is we need to rearrange the remaining ones starting from here, start at index 7 and at wherever. So this becomes our end index. So this is our start index, right? So we start from there, we keep going through the loop till we reach the end, and then at the end we'll have the next element. And now we increment our end to the next element in the array. So are you guys with me on this? So the intuition here is we start from, in the very beginning, we start from the end of array and we end at the beginning of the array, and we keep going through the array comparing till our start index is equal to the end index. And every time we do that, we increment the end index. So the next iteration, our end index will be here. And then we again start from end and we come all the way to wherever the end is. The next iteration, the end is here. See, in this example, the end was here. We start from end. So we always start from the end of the array, and we come to a point where we are not, where the element is not in the right place yet. And every time these two indexes match, it means we have gone through the array enough, and then we increment our new end location. Right? Any questions? No questions. Then let's quickly write it while the idea is fresh in our minds. Now, to do that, right. So in the find elements class, here we have find max and find min. After that, what I'll write is we let write a method called sort. So public static and it doesn't return anything. It just rearranges elements of the array uh, in an order. So we'll say, but what kind of sort? We'll call it, let's say, ascending. We'll just say ASC as a shorthand for that. And it takes an integer array. It's called input. And how? So remember, every time we start from the end of the index of the array. So what I'm going to do is I'm going to save what is the length of array. So I don't have to find that every time we have it in a variable. It's not required. It's just to make the code look clean. So I'm going to say input dot length. So I know every time where to start at. So I need to start at n. Now, how do I go in the loop? Is so I start at the end and I go all the way to 0, right? So let's say with that key. Okay. So this is index 0, 1, 2, 3, 4, 5, 6. So there are 8 elements in the array. Right? So now I'm going to say my I is 0 when the first time I'm going through the array. And let's say I have another variable called j. So my j starts at 7 and we keep decrementing j till j becomes I. Right? So when j becomes I, we know that our first element is in the right place. We have gone through the elements. Now in the next iteration, we increment I and we say, well, now my I is 1, my j again starts at 7, keep decrementing j till j becomes I, and then okay, now we are done, second iteration is over. And the third iteration, we do I equal to 2, and then again start from 7 and come all the way to 2. So we see that this I index is incrementing. How long will it increment? It will increment all the way till it reaches the end of array. Right? Because we need to kind of keep moving unless the last 2 elements are left, and then we are done. Right? So we'll create a variable and we call it int I is equal. Where should it start? It should start at 0. And how far should it go? It should go until whatever the length of array is minus 1, because that's why we use a strictly less than sign and we say I plus plus. So how do we increment I? We increment only one at a time, right? So we do I plus plus. The question is, when my I is 0 and j is 7, I have to decrement j in a stepwise manner, one index at a time, till it reaches I. So I'm going to say for int j is equal to starting at n minus 1. Why n minus 1 is because n is the length of array and the last element is at n minus 1 index. So we're saying start j at the last element. And how long to keep going till j is less than or equal to I, right? Which means, j is greater than or equal to I, we keep doing it. So we say while j is greater than I. Y equal to I is not required, because when j becomes equal to I, what do we swap? We swap the same element with same element, so it's not required. As an optimization, we can skip the equality, but you can put equal and still the program will work just fine. And how do we want to progress j? We need to decrement the index, right? So we're going to say j minus minus one index at a time. In this line 27 here, what I'm saying is start at the last index in the array, and keep decrementing, like keep traveling through the array one element at a time till j becomes equal to I, as an example, equal or less than I, which is j is, keep doing this while j is greater than I. So now when we have the mechanism to traverse through the array, what should we do every time j changes. So what we say is, if in our array, what we say, we compare these two elements first, right? So we say whatever is at index j, compare that with whatever is at index j minus 1. So j, what to do if these two are compared, and if the jth index is less than j minus 1, we swap them, right? So we say if input at index j is less than input at index j minus 1, then what do? We do a swap, right? We swap input. What do we swap? Swap the jth element with j minus 1th element. Right? It's just a explanatory thing here. What essentially this is saying is, we compare the two elements, which is compare that with this one next to it. If they are, if j is greater, then swap it, and then keep moving so far. So this becomes minus 10 and minus 20 swap. This becomes minus 20, minus 10, and then is j less than I or greater than I? Yes, j is greater than I. My j is 6 now. Compare these two and keep doing that forever. Like forever in the sense, while the conditions hold true. So we do an exchange if things. Why do we have strictly less than? What if this was minus 20 instead of minus 10 and they both were equal? Well, if they are equal, then there's no value in swapping them. They are at the right place. So we don't care about the equal condition. We care about only when the previous element is larger than or smaller than the earlier element, then swap them. Right? How do we swap? Well, it's very easy, but we write a method for that just to have clarity in our code. So we'll say public static void swap, and we'll say take integer type element, and I'll say call it array, and swap what? Swap whatever is at index I with whatever is at index j. Swap those two elements. How do we swap? We do an int swap. We first save whatever is at index I into a variable. Then we do integer I. So update. Now, as we have saved whatever is at I, we can update it. So we'll say whatever is at index I is equal to whatever is at index j. And now update the element at index j with whatever we saved in the temporary variable swap. This is kind of a little confusing because our internal variable is same as a method name. So we'll just change the method name and call it exchange instead, right? Ch, just exch. And then we call that method. So now this method is going to swap the elements. We did the exchange. And then are we good? I think we're good. This is it. This will sort the whole array into an ascending order. Right? So let's quickly test it out. Now, how do we test it out? Okay, let's just start out. Fine. We can call that method from here. But then what I am inclining to is to let's write our test code where the actual program is. That way we don't have to kind of jump through the files and kind of do so many things. Input. Why is it saying? Okay, my program is not liking something. Okay, here it's not liking the typo here. Okay. To test our program, we'll just write another method, public static. We'll say run. Whatever is in this method will be run. So first, we need to create an array. We'll say in ARR. You can just copy paste whatever we have here, and we'll just say numbers. We'll just copy paste. That is our array. Now let's print the array first before we see if it is sorted or not. So we'll say system.out.println array before sorting. How do we print elements of array? We'll say just go through each element and numbers dot length plus plus. We'll say system dot out dot println. What do we print? We print number, whatever is at index I, and then we separate them by space just to make them look better. So once we have printed the array, just so that we can see it, we need to sort it. So let's sort in ascending order, and what it takes as a parameter, it takes numbers as parameter. And now once this method returns, our array is actually sorted. Let's print out and see is it really sorted. So we say print line array after sorting. To print it, we literally copy paste the same code. Okay. You all have this running. So I mean written so far. Can I move to? Well, there's another question here to think about. Is as you have decided, we are going to call the run method, which is going to run the program for us in this class. We don't really have to have these as public because we're not going to call them from outside. We'll just make it private. No one can call this. When we make that private, do we really need static? We actually need static. Why? Because they are being called by run right here, and that is a static method. So static methods can call only static methods, or they can only access static variables. That's why we need to have those as static. Now let's run this. How do we run this? We come back here to the main.
Oh wait, can you go back? I still haven't finished. And what was the thing you changed up above?
A few things I changed is first I made them private.
Wait, all of those.
And second is I updated the method name just in case if.
Oh yeah. All right, yeah, then I'm done.
Okay. So if everyone is done.
Second. Sorry, I got kicked off the call because of my Wi-Fi.
Sorry, what did you say?
Nothing. Never mind. It's good. Thank you.
Okay. All right. So we know main is the entry point in Java. So the Java program is going to start running from main, and from here we'll call that method that we just wrote, and it is in find elements dot, let's say, run. And what we expect is we expect to see array being printed as is, and then again printed in ascending order. So let's run it and see if that's the case. Well, actually it did print it as is. You can compare it with line 129 in the code here. It first prints everything 5, 130, 0, 15, 2, negative 10, negative 2, 20, and then it arranges them in ascending order. So the program works, the sorting program works. The display is not that good. So let's fix it real quick. What is happening? It's printing everything in new line. So we don't need to print everything in new line. That's too much. we're going to remove print instead of print ln where we print the array. We just use print, and then let's run the program again. And now at least there's some betterment. At least the array is kind of printed in one line. So our program is working. We're just trying to fix few things here and there and make it.
I have a question.
Yes.
It's not letting me run mine. Like the run button's like all grayed out and stuff.
The run button is grayed out.
Yeah.
So for that you need to go to where your main is, and you're saying your run button for the main is grayed out.
Yeah. In the main, there's no little run button next to my main like method. That's what I was wondering about.
Okay. Do you want to share your screen?
Okay. Like it should be like right here, but it's not there.
All right. So I did not there. Do you have multiple names? No, just one. Okay, go to run on the top, and then see if you can.
When I hit this, it just brings up this window.
Okay, click on that. Looks like your program maybe has more than one main. Okay. All right, do a cancel. This used to run before. Okay. On on the top where the array program or Java tab is, go to the left side of it, and you see there's a crosshair. It's like a setting icon. Make sure that is a
This?
and then the crosshair. Yeah, click on that. Okay. Double click on hello string.
Hello string.
Okay. Somehow your program thinks that's where the main is, and it has not picked up change location of it.
Yeah, because I commented this out too, so it shouldn't.
Yeah. So for now, what I'll recommend is uncomment this, because this main will work, and then call your program from this main, and then we'll fix it. We'll fix the problem later. It just requires some setting change.
So you want me to like copy everything now?
Yeah. And you can comment out this main in this class. Then.
This. Like that.
Yeah, save it, and then go to array programming, the previous array program, and then
This. Okay.
yeah, comment out the main here just in case.
This one.
Yeah, the whole method, not the class, just the.
Wait, hold on. This does have static in it, right?
The class is fine.
Oh, it doesn't matter.
Your main doesn't have static in it. That could be another reason. So maybe after public in main, see there's public void, maybe public static.
Main.
Yeah, put static there.
Okay. Then do my other one.
Yeah, see the arrow comes up, right? So go to hello string. Yeah, then you may have the same problem in hello string. Oh no, now you don't. So you can just undo everything here because now your program is back in action.
All right. Now, I hope it should work when I run. Okay, cool.
All right, so it is working, and now it's printing everything in ascending order, right?
Mm-hmm.
All right. Okay, so now when we all have it working, there are a few things that you can improve. First is every time you need to print contents of array, we have to write this whole thing, which is um, which is unnecessary. We can simplify this by making a method which prints, which pass an array, it prints for us, right? That's one optimization. Advantage we get is, as an example, we had print line here. We had to change two places. The same change was done twice. So having a method kind of makes it easy to make changes, changes at one place rather than multiple. So let's kind of make a method which does one thing, which is to print contents of array. So for that, let's create a class, and we'll call it array utils. Because we're going to use this to write methods which help us with with added related activities. So let's call the method as public static void print array right? It'll take his integer type array, and the only thing it'll do is it'll just print them all. So for int I in the array, this is the advanced for loop, which doesn't require to have an integer I and starting at index 0 to blah. It's just saying Java that go through every element of array. Every time you go in this loop, assign that value to the next index in I, and we print it. It's a system.out.print, which is 9, it's a print. What do we print? We print whatever is the value of I plus we put a space, and at the end, when we have printed everything in one line, we just say print a new line, so that everything following this method call gets printed in the next line. Why do we need that? Is because we saw here in the output, see how the array after sorting gets printed right next to the previous output. So we just don't want to do that. So that's why we're kind of putting an extra print line, which will print everything in the next line. And when we have that, let's use it. So we'll say.
Sorry, can I see that again? The arrays util.
Yeah.
Also, I have one question for text. So you remember how you taught us how to like add a new line by just typing like /n or something?
Yeah.
How would you like type that into the code? I've been trying and I can't figure out exactly. Like, how should it be formatted?
Say, it is new line. So okay, let's look at it again, right? So in this case, what this is going to do? Okay, I'll come back to your question right now in a moment, right? So once you're done with this, let's go back to find element, and we'll delete that for loop, and we'll say from array utils dot print the content of my array, and what is my array? It's the numbers, right? Similarly, we'll say array utils dot print contents of my array, and the same array now it's sorted. So now our kind of this code becomes easy because we have moved our common code there. Now let's run this and see how our output comes out to be. We run this, and there it is, right? Everything separated by one space, and then everything neatly placed in a different line. Now coming back to your question of how to use a new line. Let's say instead of printing everything in contents of array in one line, we want to print them each element in an individual line. So we'll say which means print the element and then put a new line. So if you run this, see how each element is printed in a new line. So the element I is printed and a new line is inserted. Then the next element is printed, new line is inserted. Does that help you with?
Yeah, no, what I was thinking was that, so I wanted it to be like the array before sorting. Instead of making a new line after that and then saying it, I wanted it to be array before sorting and then all the numbers, and then in the next line, next line array after sorting, and then all of the numbers are the same line. Like it should be only 2 lines with all of this
Okay.
stuff.
Okay, got it. So for that case, okay, now I'll remove that. Let me remove this as well. Let's intuitively develop it. What we're doing here is we want to print all the contents of array in one line. So this is going to do that. Now the ask is, can we not have array before sorting in one line and everything in a line following it? Can we have all the elements just continue printing in the same line? Yes, we can. Now why is it printing this way? Is because we are using the method print line. So it prints the content of whatever we pass as a parameter, and it inserts a new line for us. So we'll just remove that. So we're saying Java, don't put a new line. So just we'll call the method print. That way, Java will print the parameter, and whatever we are printing after this, we'll just it'll keep getting printed in the same line. Let's run this. There it is. So it kind of fixed one problem, which is
Yeah, that's what I have right now.
yeah. And now we run into another problem is, okay, now the second print is also in the same line. How do we solve that? Well, we can solve in a few ways. First is we know that we need to go new line after the array element. So we say that, and then this will fix it. But should we really do this is a question. The reason is probably not, is because when we are writing the print statements, we have to know that the method that we called previously is not printing any new line. So we need to print it ourselves. So we need to know something about the system before using it, which is not good all the time. So what we can do here is instead we can put a new line here. In this case, the method will take care of putting the new line for us, so we don't have to worry about it. So even when we just say print, the next is going to get printed in the next line. But it's up to it's kind of it's a personal preference.
So what did you do in the arrays arrays util one? What did you
So
change instead of the slash n?
Yeah, I just added a print line. You can achieve the same thing by calling print and then slash n. It's one and the same thing.
Okay.
Yeah.
It's just that you don't have to add it to everything else, right?
Yeah. All right. So now we have the sorting. We just implemented a bubble sort. The question is, how, as a programmer, we should be mindful of, are we writing optimal code or are we not? So we just sorted this whole array. Any recommendations on if we can do better? How can we improve this solution? Okay, first of all, before we talk about improvement, what is the problem with this solution? What is the problem with sorting? Well, bubble sort is a non-optimal solution, which means there are better ways to sort. But let's just talk about the bubble sort that we implemented. What are the problems you see?
I think one of the problems is that it takes a long time, and it doesn't take as long for us because we only have 8 values. So if there's a lot more, it would take a long time for it to like check between every single input. So it would be very inefficient in like larger scale stuff.
Yes, that's right. And you know what? Let's quickly give it a try. How about this? Let's write a program that generates array for us. And we can't with this small tiny array, we'll not be able to see the problem. So for this, we need a little bigger array. And let's write a program to quickly generate an array of whatever size we want. So we'll call this method as now. It is array related thing, so let's put it in the array utils. So we'll say public static void. Or do we need a void? No, we need an array in return. So we'll say integer type array and generate. So we'll say gen uh, uh, array with random elements. How big of an array do we want? So we'll ask the user for it. So we'll say, tell me the length, how big you want. Um, and the question is, how will we generate an array and what numbers will we put in it? And I think we have come across, we kind of used random before, and random can generate a random number. So the idea here is that we create an array of whatever length user wants, and then we'll insert elements into that array randomly in a given range. Now, what should be that range? It could be anything. We can say generate a random number between 0 and let's say 1000 or 10,000, could be anything. So why not take that from the user as well as a parameter? So what range do you want? Int lowest value you want all the way to highest value you want. So we take the range from the user. And now we'll start writing our program. So we'll say, what is our range? Our range is high minus low. So we need to generate numbers between this range only. Now, if more of a safety check, array length is less than or equal to range. You know what, let's put this check when we run into problem. Let's not worry about it now. So next thing what we do is we'll create an array. We'll call it ARR is equal to, how do we create a new array? New integer array of what size? We'll say of array length. We create an array. Now we need to populate it, right? So we create a random object. We call it random is equal to new random, right? We get a random object so that we can create random numbers from it. And how do we populate the array? So we go in the loop. We say starting at index I equal to 0, go all the way to array length, one index at a time, and at every index in the array, generate a random value and insert it. So we'll say low plus random next integer in the range. So that will generate a random array, and once you have generated that, you return the.
My code is having a problem with random in line 15 for me, 17 for you. Like when we just say random equals new random. The capital
So
random is, yeah.
I think you are missing the import.
Oh, okay, yeah.
Yeah. So one way to avoid running into such problems is you can just type like few alphabets and then just hit uh, control and space. So IntelliJ will kind of automatically import those things for you. Okay. So everyone with me so far? So what we are doing here is essentially we're generating an array of whatever size user wants, and we are generating numbers between whatever range the user has given. So this method is going to do that. And I'll just simplify this. Right? So everyone has written this. We're going to use it. Now see here, we said integer number, and then we gave it a number. Instead of that, now we can call the method and we'll say array utils dot generate array with random elements. How big of an array do we want? Let's call it, let's have 200 elements. The range of, let's say, minus 200 to.
I have an error.
What else do we have?
It's on array utils.
You have error in the array utils. Okay.
Yeah.
Where do you have the error?
It says, let me hover over it. It says identifier expected.
Which line? It's the random. Do you want to share a screen real quick?
Yeah. Oh wait, never mind. I just saved it and it fixed.
Yeah, that can happen.
My bad.
All right. So we come back to our program and we say generate an array of length 200, and then the numbers that go in that array can be anywhere between minus 100 to 1000. It can be anything. I mean, let's make it minus 1000 to 1000. Let make it even range, and then let's run this and see what we get. So essentially, it's a big print statement here, but that's like 1000 elements printed. Not 1000, sorry, 200 elements printed for you. Now, if you keep running this, it'll have random numbers in there. So it's going to generate a random array for you all the time. But the beauty here is, now we don't have to worry about creating our array. We can just use this method and we say, oh, we need an array of length 10. Just make that 200 to 10, and now it'll just generate an array of length 10. There it is. Length 10 elements in array 10, 3, 3, 6, 7, 8, 9, 10. Yes, right? So it's doing the job. Now, real quick, we are running low on time. What we are going to do is we're going to time it. We are going to see how long does it take to sort the array. All right. So for that, we say long start time equal to system dot nano time. Let's saying start my timer here, and then sort my program, and then I stop my timer. Timer system dot nanosecond, and then what it is doing is Java is saving whatever time in nanosecond is at this moment in time, the start time, and then it does a sorting, and then it saves current time in nanoseconds as stop time, and we'll see how many nanoseconds elapsed between those two. At the end, let's find out how much time our program is taking out of print line and elapsed is how much time has elapsed? Stop timer minus start timer, those many nanoseconds. Okay. Let's quickly run our program and see what we get. So to sort 200 element array, it has taken 715,000 nanoseconds. Right? Is that a lot of time? Well, it's not even a second. So it's pretty fast. But let's quickly now at this point, which is once we have sorted the array, we know that the array is sorted, right? What happens if you sort the array again? Should it take less time or same time? If we try to sort the sorted array, what happens? Any guesses? Then we'll find out. So now we know that array numbers it's sorted already, and we're going to sort it again. And now we find the new start and end time. see how much time it takes. Let's run this. So sorting one time took like 900,000 nanoseconds. Sorting it again took like 436 nanoseconds. Well, there's an improvement, right? Now, why is an improvement there? Is because we are not swapping elements because they're already sorted, they're at the right place. So we're just going through the array. Can we do any better? Can we improve this time? So we are taking, if we have an previously sorted array, we take half the time to sort it again. See, from 900,000 nanosecond, we reduce to 400 nanoseconds. Now, can we do better? And the answer is yes, we can do better. So once we go through this loop of, so let's say if the array is previously sorted, we don't have to go through the whole array because it's pre-sorted already. So we can just use that and break the loop without kind of going through every element. So we'll say change is equal to 0. And every time we do an exchange, we'll say exchange plus plus. But if we have not exchanged anything, which happens when array is already sorted, we say if we have not exchanged anything, then we don't need to do array is already sorted because we have not exchanged anything. Let's say if this improvement makes any difference. Right? Oh, well, okay, fine. So we'll save this for our reference. I've copied it just in case we can compare it later. And let me run the program again. There it is. The first sorting took kind of about 800 nanoseconds, 800,000 nanoseconds, was like 100,000 nanoseconds less, which is kind of comparable. But look at the after sorting, it just took 5,000 nanoseconds. It's a huge improvement, right? So what are our earlier values? Let's do a comparison. So our earlier values were those, and then our new values are these. See the difference here? That's like maybe like 1,000 times faster. Right? So the computer runs so fast, we don't observe this at human scale, but at the scale of computer, you can see how just writing one line here made your program run 1,000 times faster. So this is where a good programmer is distinguished, is how optimal you can write a program. Right? And this is mind that this is only 200 comparisons we are doing. Just imagine if it was like everyone on Facebook and you want to go through everyone's account, and these are like huge numbers, like millions of numbers. Let's say in this case, well, it will fail the program, but like if you have huge numbers, we'll see that the time it takes to run the program gets longer and longer. From that 800,000 nanosecond, we'll see now it is like 6 million nanoseconds to sort 1,500 elements. So we see if you run this again and again with more number of elements in an array, you'll realize the time it takes for a program to run is exponential. It's 2 raised to the power of n. So that's not, well, actually it's not 2 raised to the power n, it's n square. So it takes double time every time the length doubles. So that brings us to the end of our today's session. Let me know if you have any questions. I'll stay here for some more time. Else you can drop off, and we'll continue writing programs next session as well. We'll try to improve the solution. You all have a good night. Thanks for
Thank you.
Thank you.
Thank you.
Thank you.
Thanks.
Bye.
Bye.
Have a good night.
Thank you.